Hello, hi guys, good morning. And although I did this question with segment trees lazy propagation, but I found out that it's not the optimal way or the easy way to get the solution. So yeah, here is the video for the best possible solution in all the languages, because every language has some or the other thing that okay, it's not possible in Java, it's not possible in Python, it's not possible in C++. So I have all the language sorted for you guys. So yeah, here we go at this question, handling some queries after update. So basically what the question says is that we have given a zero index integer array nums1 and nums2, and also the queries array, which is a 2D array. It has three types of queries. First query is query 1 is that I will be given one LNR, in which that I have to flip all the bits in the range L to R, which means flip the bits means 0 to 1 and 1 to 0. I have to do it for the entire range L to R. And for the query 2, what we have to do is that we are given an integer P. So basically I have to do a nums of I into P plus adding every element. So basically it indirectly says is that just count the number of ones in nums1 array and just multiply it by P and add it to the sum of nums. What it means is that nums of I is what? Nums of I plus nums of I into P, and it will only matter when this nums of I is 1, right? So it just says that if my nums of I for that particular I is 1, just add a P in my nums of 2 of I. Cool. Now the third query, it just directly says is that just give me the sum of the elements of nums of 2, which means that I just need to have the sum of nums of 2. Let's quickly have one example. It's pretty simple. It just says that okay, the nums1 array is 101, nums2 array is, let's represent it as n1, n2 array is 000. In the first query I am given as a query 1. Query 1 is when the first thing is 1. If it is 1, then it's a query 1. And it says that L to R, which means from 1 to 1 I need to flip the bits from 1 to 1. If I take my array as this 0 1 2, so from 1 to 1 I need to flip the bits, which means I need to flip this number to 1. Okay, cool. In the second query it says that from 2 1 0, which means that it's a query 2 as the number is 2. What is my P? My P is here. My P is 1. So what I need to do is that I need to do my nums of 2 plus P. As I said, it will only be added when the number is 1 above. As I showed you guys that it will only be added when the number is 1, right? As my index 1 is 1, value of nums of 1 at index 1 is 1. So I will just add a P, which means I'll just add a 1 here. Here 1 is P, right? Now, okay, now what is the query 3? Query 3 means that this first thing should be 3, and it is 3, so it's a query 3. In this, I just have to return the sum of this nums of 2. I'll just return it as 1, and it is the, sorry, okay. So in this, you are also given that 2 1, yeah. We have, what we have to do is nums of 2 plus P for every of nums of I, right? So as the 1 is here also and the 1 is here also, so I just have to do addition at every of nums of I, nums of 1s of I where it is 1, and just I'll return my answer as 3. So I hope that you guys got the question. Although if you see at the constraints, then it will be very evident that my nums of I, nums1 and nums2 is 1e5, which is pretty long, and the queries is also 1e5. So I'd have to do anything such that I have to pre-compute answer, or maybe at runtime I have to get answers for every query in O of 1 time, which means that if my query says that okay, update from L to R in this range, so I can't do it in O of n. If my range says that okay, make it the sum, so I can't do it in O of n. If it says to return the sum, I can't do it in O of n. I have to do everything in O of 1. Cool. Now look at very simple thing. Let's say my nums1 is like this, for example, 1100101001, and nums2 is, let's say, 87. I have a random for just better example of that thing. So my query 1 looks like this. Let's name it as q1. It will be as 1 lnr. q2 is 2p, and anything after that it doesn't matter, and q3 is just a 3. I need to have a sum here. I need to multiply, which means that I need to multiply nums of 1 of I into p, which means that everywhere where nums of 1 is 1, I need to just add a p for that corresponding one. It just represents this, and q1 is just, I have to flip the bits. Now if I just think that, okay, if my q3 was the only query I had, then what I would have had to return? I would have had to return the sum of this. Agree on that part? If q3 was the only query I had, then I just would have returned this sum, which means this sum, let's say pre-compute this sum and just return it in one step. Agree? Okay. What if my query was something like, it was first q2 and after that it was q3. If it was first q2, then what would I have done was, I have just computed, okay, how many such, if you guys see this thing, right, nums of 2 of I equal to nums of 2 of I, which means nums of 2 of I is nothing but nums of 2 of I plus p into if the 1 is present or not. Right, I'm writing like this, if the 1 is present or not. If, see, I just have to do operation like this for every nums of 2 of I, but ultimately I need to find the sum, right, for that nums of 2 of I. So let's say I am computing the sum here. So the sum of nums of 2 of I, it means the final sum, which means the final sum, it's equal to what? The nums of 2 of I previous sum, which was earlier, let's say as previous sum, plus p into, p was that thing which I had of query 2, it was p of that, right, into what? Into 1. But 1 is also sigma, which means that number of ones I had at that time when I did the query 2. Correct? So which means that it is the number of ones at this moment when I did the query 2. So what I can do is, at every query 2, what I will just do is, at every query 2, I'll just update my sum with the sum plus that p value into number of ones in num1, which means that here at this moment num1 has 1, 2, 3, 4 and 5. So my updated sum would be sum equal to sum plus 5 into p, whatsoever p it has given. Now we have understood how we have to think for if we had a query 2 and then a query 3, and then I can just return this sum as I have already computed it at query 2 step. Very correct. Now what if my query would have been like this, query 1, query 2 and then query 3? If the query 1 would have been there, so it directly says that I have to, if q1 is something like this, 1 ln r, so it directly says that I have to flip the bits from range L to R, which means that whatsoever, if the bit is 1, I need to flip it to 0. If the bit is 0, I need to flip it to 1. Number or bit, let's have same thing. So which means that I have to flip the bits. In query 2, I have to count the number of bits in num1 and then multiply that by p as I showed you earlier, and then add that thing in my sum, right, and the sum would be okay, and I can return that in my query 3. So now you guys will wonder, okay, Aryan, okay, we just understood that we will compute the sum for every step, every query. We will update the sum by the previous thing, by the count of number of bits or number of ones in my nums of 1. Okay, but Aryan, there is one issue. You said that I have to do it, I can't do it in O of n, which means that I have to do it in a shorter time to count the number of ones in my nums1 array. Okay, it's a one task, it's one task which I have to count the number of ones in nums1 array in less than O of n time, and also I have to flip the bits in the range L to R. When I say flip the bits, it means that 0 to 1 and 1 to 0. And I also can't do this step in O of n time. I have to do it in less than O of n time. Now we have two questions in our hand, and now we will solve these two questions. So basically, the first question, like if we move up, the first question was that at every query, we need to get the count of number of ones. In what? In nums of 1. After flipping the bits, right? So what it does, when we say flipping the bits, which means 1 is turned to 0 and 0 is turned to 1, what operation can you think of which can do the flipping of bits? Simple, it's a XOR operation. How? See, if you had a 1 and you want to convert it to a 0, if you had a 0, you want to convert it to a 1, what's the best operation you can have? You can just flip with the help of a 1. If you had a 1, no matter whatsoever number is there, you can just say, okay, if any number is there, I can just have ones, and if I have this 1 in this range, then every bit in that range would get flipped, right? Cool. So basically, what I got to know now is that whatsoever range I have, L to R, if I want to flip the bits in L to R, I can just make a mask. See, earlier we were thinking in an array form, but that array itself is of 0 and 1s. So maybe we can think in a bit form. It's just a nums of 1 array, right? So it was of 0 and 1. Let's think in the bit form only, right? Cool. So basically, if we want to flip the bits in the range L to R, how about I just make that L to R range as 1? If I make this L to R range as 1, as you can see here, if I make this range L to R, this range L to R as 1, so if this is my nums, if this is my nums of 1, then it will just get flipped to nums of 1 by just these things, which means that because of these 1 1 1 right here, the range L to R I said, let's say 3 to 5. So the size of the window would be R minus L plus 1, right, which is 3. So the window of size this 3, which is from L to R, which is from 3 to 5, it got flipped entirely because of that 1 1 1 right here, right? Now you had a question or you had an answer. You can stop this video, and I guess if you had the language, maybe Java, Python, you can probably solve it. Why I'm saying this? Because to do this operation, let's say first operation was to count the number of ones. So basically I can just have an integer, let's say in Python or something in Python, like let's talk about Python now. I can have an integer and I can represent that integer in the binary form, because the Python, it can have a very long number, very long number. So I can represent any number in the form of a binary. So I can just do a dot bit count in Python and get the count of the number of ones in that array or in that integer, which is now in a binary form. One thing is sorted. If I am in Java or C++, I need to use a bit set. Why? Because Java and C++ don't support a very large number. Java and C++ don't support a very large number, which means that when I say a large number, it means that, as you know, that the size of this array, it can be 1e5. If I want to represent a 1e5 length array in a binary form, so I need to have a 1000 up to 1e5 length, right? Which means that it can be 2 into 1e5, 2 raised to power 1e5. which is a very, very long number for C++ and Java, so it can't be supported. But we have a bit set in Java and C++. With this help of bit set, what we can do is we can simulate the operations which can be done on an integer array when it is on an integer when it is in a binary form. Although in Python you can do it easily. So now the person who codes in Python, he can just write, I'll show the code in the end although, but he can just go and write the code himself. It's done. It's just, he just have to simulate this whole thing and he's done. For the people who code in Java, and like the worst one are the ones like us who code in C++, have to struggle. Now how? See, now my main task is to create this kind of mask with which I can XOR and output this number, which is nums of 1. So I can output this nums of 1, and with this outputted nums of 1, let me take it green. So with this outputted nums of 1, I can just apply a count function to count that number of ones in this bit set array integer. Let's say I can just apply the number of ones. I'll find number of ones in this by Python by a.bitCount, in Java by a.cardinality, and in C++, if it had been an integer, so it would have a.popCount, but it is not. It is a bit set, so it would be a.count, and it is same for Java. It's bit set, so it's a.cardinality. In Python, it's just an integer, so it's just a.bitCount. Now we have one thing sorted, which was to count the number of bits in nums of 1. Now it can be done in O1. Now the other step was to flip the bits in the range L to R. So now to flip the bits in the range L to R, Java for that particular bit set has an operation that is just, if the bit set name is, let's say, B set, so we can just do B set dot flip L to R. It can flip the numbers in the range L to R, but it's not the case with Python and C++. So yeah, let's see how we will make this mask, which I showed you right here, of XOR, so that it can be used to do a XOR with nums of 1 and get our answer. Now our operation is to build this mask of 0, 0, 0, 1, 1, 1. 1, 1, 1 is of length size SZ, which I name as SZ, and from what? From L to R. Okay, cool. Now what we have to do is, let's simulate this thing. So in C++ or in Python, how you can do is that firstly I took, as I said in the beginning itself, in Python you can have a big integer. So whatsoever I'm showing right now, in Python you can simulate the whole thing as an integer, but for C++ you have to simulate it as a bit set, which is just an array of ones and zeros of bits, you can say. Now you have this, right? I took a bit set, let's say B, initialize it by 0. Let's say here the size is, although it's 8 or more, but let's say, although in our question it would be the size as it is constant, so it would be 1E5, but here for the simplicity we took it low. Now we took it initialized by 0. See, don't forget maqsad kya hai. Maqsad was to make something like this, that from left it should be at index 3, should be of length 3, and then rest all is 0. So you should never forget what is the aim here. So what I did here is that, okay, I'll just have this, I'll just flip all the bits, which can be O of 1 operation. Now I'll do the left shift by left shift of size. With the left shift of the size, I will be able to achieve a 0, 0, 0, a 0, 0, 0 of this length size. Why I wanted to achieve? Because next time what I will do is I'll just do a not operation, and this ones will become zeros and this zeros will become a ones, and this one I can use as a window for doing my XOR. Now it is, the window is of correct size. Good, we are good. But it's at wrong position. It should be, as I showed you, the window, it should be how much? At my L. At my L. So I need to left shift my window. If my window is like this, I need to left shift my window by what? By L size. So I showed you the same example here again, which I had above. So here it's my window right now, 1 1 1, right? Although I've written, see, the array goes like this, but the bits goes like this. So you can have confusion that, okay, array is written like this and the bits are written like this. So, but understand, I have just marked the indexes as 0 1 2 specifically for you guys also, that okay, now my window, I have 1 1 1 of size 3, but now it's at wrong position. I just need to change the position. However, I will change the position. I'll just do a left shift by how much? By this L, by this L, so that it can just get left shifted by this L, and it just occurs here. It just got left shifted by this L. It is the size of the window, which is the mask of that 1 1 1 of this length size, and the remaining all for sure will be 0, because as I said, we just flipped the entire thing here by a NOT operation. Now you got a mask which you can apply on your nums of 1 and just get updated nums of 1, and with this operation and by a simple count operation you can just get, okay, how many number of ones are there in this bit. So it's easy, right? In both Python and C++. In Java, it's super simple. You just have to say, just let's say our bitset name is bset.flip, and it will just flip it. I'll quickly show you the code, and it's both in C++, Java, and Python. Specifically, first let's see in C++. So basically, I took my answer. Here is the bitset of size n. When I say n, I defined n as, sorry, it's not visible here, but I defined my n as 1e5 plus some constant for just as bit safety. I just do like this, but yeah, it should be defined as constant because at runtime it can't just take a n by yourself. Now my sum is just the sum which I will update at every Q2 query, and bitset is of 0 is the thing which I showed you guys that I have initialized. If I, as I showed you, right, I initialized here init b init, I initialized with 0, right? It's the same thing I did. I initialized with 0, I flipped it, which means that if you see here, what I did was I just flipped the bits here, converted every 0 to 1, did the exactly same thing here. Here I just did what? I just made a b set out of those nums of 1. So it's just converting that nums of 1 to a b set, and also having the sum for just Q2 query, right? As I said, at every Q3 I just need to return the sum, and how I will compute the sum? I'll compute the sum at every Q2 query. So I just computed the sum first. Okay, good. Now I just move on to my main queries. If the query is 0, then I'll perform these operation. If the query is 1, then I'll just see the number of counts of 1 in my in my nums1 array, which is actually representative of b set. As I said, I converted my nums1 to a b set. So I'll just count the number of ones in my b set, multiply by p, it is p, and here I will just add in my sum as I showed you guys. Now if my query is Q3, I'll just push that in my answer vector. Q2 was the part I explained very briefly. I'll just firstly have a size. I'll just make my array something like this of size. It is the size. Then I'll just, it was 1 1 1 1 1 and 0 0 0. It was size, and then I'll just do a flip to get this size as 1. Here is the flip operation, which is the not operation. Then I'll do a left shift of L, which means that it is the size, and here it is the L, which is it will get left shifted by, and it will move on, go on. Here it is. And then I'll just do a XOR operation, which was the final operation to get the bit set, correct updated bit set now. It is the code which you have to do in C++. If you see in Python, sorry, in Java, sorry, it's in Python, that is just the same. Here the case is that you can initialize a very long number. If you make this operation in C++ or in Java, it's not valid because you just can't initialize, because the L length, it can be 1E5, right? So it's not possible for you guys to initialize this in C++ or Java, but it's possible in Python. So yeah, it's the only change which you can have in Python, and you can just follow the same code which we above learned and saw, and you are good to go. Let's see in Java. In Java also, it's more or less same. Everything is same, that we have to flip the bits and all that stuff. Just one thing, that here the whole operation which you performed to flip the bits here, you can just do a flip range L to R, and it will just flip the range L to R for you guys, and you don't have to worry about flipping the bits manually. So yeah, it was the Python, Java and C++ code for you guys. I hope that you guys like the video. If yes, do hit the like button, it motivates a lot. And yeah, see you guys next video. Until then, bye bye.